So, new packaging concepts. A couple of ground rules before we start. First, there's no way we're going to cover everything in 40 minutes. Two, this just isn't about new packaging concepts. It's also about where new packaging concepts and innovation come from. So I'm going to be talking about some specific examples of new packaging concepts, but I'm also going to be talking about, and I want to get you thinking about, where does new innovation come from? And maybe broaden the box in which you think about it. So just as a bit of a spoiler, it doesn't all come from your packaging suppliers. In fact, the majority of it doesn't. And we'll talk more about that as we go on. So, what is fresh cut packaging? We've already talked about that. Hopefully you've got an idea. There's all kinds of different sorts of packaging out there. They do all sorts of different kinds of things. Some of you should see some very familiar looking packaging up there, right? And it's a global, and I showed this slide 2 days ago, it is a global activity. There are things going on all over the world that affect packaging and new packaging development. So make sure you go to, if you can, some of the global trade shows, some of the global innovation shows. You know, Fruit Logistica, small little show in Berlin every year, every February, 85,000 of your closest work colleagues and friends descend on Berlin for a trade show that has 36 halls and is 5 miles to walk. It is amazing. I encourage you all to go there. So where does innovation come from? It comes from the consumer. Consumers drive innovation. Produce drives innovation. That's a lot of it. Spiralized vegetables, fresh cut eggplant, all of these new kinds of produce items that are coming on stream. And there are, of course, new packaging technologies. And then there's new marketing, branding, recognition. How do we set our package apart from our competition's package? That's all part of packaging. And then at the very end, we're going to talk about Jeff's truths. And this gets back to what it can and what it cannot do. And if there's questions, you all ought to know me well enough by now. Raise your hand, stand up, shout, jump up and down, get my attention in some way, shape, or form. So from a consumer standpoint, and it's interesting, I was telling somebody at lunch, this is my 14th year of doing this. This one, when I first started teaching here, was not even on the radar. We didn't even talk about food safety, or if we did, it was very little. Now, from a consumer standpoint, now it's still numero uno. Jumped right up there. Convenience, freshness, quality, sustainability. We're going to talk about sustainability towards the end of this talk quite a bit, and what does that mean? Locavores. Do you guys have locavores out here? Do you know what a locavore is? Local foods. Will only eat foods within X number of miles of their location. Now, I live in New England, which happens to be beautiful right now, ladies and gentlemen. I mean, spectacular. But if you're a locavore in New England, you got to love root vegetables. Because our growing season is about 8 weeks in the summertime, and the rest of it, it's stored vegetables. I mean, I always get a kick out of people in my hometown, oh, I'm a locavore. Well, what do you do from late October until early May? Because there is nothing fresh coming out of New England unless it's grown in a greenhouse. And that, of course, is changing very dramatically. And year-round produce availability. You know, people now want strawberries on Christmas. People want their kiwi in the middle of January. Probably not coming from Vermont, even in a greenhouse. So you've got this contradiction between people who want local produce and the general public that wants year-round produce availability, and that drives innovation. And then we have the C word that was so eloquently pointed out on Tuesday by my learned friend here, cost or economics. Also drives innovation. So, We have new vegetables coming out there. Not the vegetables themselves aren't new, but deciding to try to work them into a fresh cut format. We have fruits still coming on strong, and a lot of more global fruits that generally are not found even in California. People are now looking about how can we get that into a fresh format. Novel geometries, the spiralized vegetables, which have started to tail off, but for a while it was all the rage. You know, anytime you change the geometry of a fruit and vegetable, you change the respiration rate. Therefore, you have to design a different kind of package. And then the one that I've talked about a number of times, this combination of protein, carbohydrate, and produce, or a ready meal. And you're seeing more and more of that. You see the Blue Aprons, you see the Sprinleys, you see the Plenties. All of these companies are looking at ways to do a home delivery of a ready meal kind of application. You also see now fresh soups. Curation Foods has got a line of fresh soups coming out. Ready Pack has a line of fresh soups. All of these different things that traditionally haven't been part of the fresh cut produce market are now becoming mainstream. Packaging innovations, and we're going to talk about these in more detail in just a minute, but there are actually a lot of new things coming on stream in the actual world of packaging, whether it's polymer packaging or whether it's paperboard packaging or a combination of. And then of course sustainability is a big area. It's a big area of innovation, and it's an even bigger area of marketing hype. And so we're going to try to talk about that in just a little bit. And then the various marketing requirements. How are we going to separate what we do, what you do, from your competition? How do I make it look so that on a retail store shelf, people are going to grab mine versus the company next to mine? So the future really is now. And of course, because I'm me, we are just going to step back for 1 second and remember that this is all great about new innovation, but if the package leaks, or if it's designed improperly, or you're not controlling O2 and CO2, is that new innovation going to work? No, it's going to fall flat on its face. You still have to remember the fundamentals. It's great to design this new package with new polymers or sustainable biopolymers and all this stuff, but if you shorten your shelf life or you have poor quality on the shelf, it doesn't matter how sustainable it is. People aren't going to purchase it because the quality of the produce is not good. So, back to the future. We talked about global innovation. We talked a little bit about European technology. Now, it's interesting. How many of you spend a lot of time in Europe? So, on the one hand, we're far advanced in Europe, more than Europe, and that's in the area of leakers and package integrity. We do a much better job of making sure we have a leak-free package than the Europeans do, and that is based on geography. The 15 days, the magic 15 days that people talk about, is based on 5 days to get across the country with 2 drivers, 2 days of production, and the American consumer still likes to shop as a whole once a week. And then you have a few days on the grocery store shelf. So there's your 15 days of shelf life that you need in North America as a general rule, 15 plus. In Europe, not so much. Refrigerators are much smaller. People shop on a more regular basis. They buy almost every day. So 3 to 5 days of shelf life in Europe, 7 days, is more than enough. So leakers and package integrity has never been historically as important in Europe as it is in here. But innovation in Europe is leaps and bounds ahead of us. I mean, back when I first went to Europe for produce reasons in 2003, they were already combining, when we were barely just doing iceberg, they were already combining sauteed shrimp with peppers and a sauce in a multi-component fresh cut package. I mean, innovation was so much as far as novel combinations of produce and putting unique things together. Europe was so far ahead of us. And they could do that. Well, first of all, I think the European palate is a tad more sophisticated than the American palate, certainly my American palate. So there was a market demand for that, but also because of the shorter shelf life, they could do these things without a downside. Now, what's happened over the years is Europe has started to focus more on package integrity, and we've started to focus more on innovation. So the two are starting to come together with how we look at things and how we do innovation. But it's still, I will tell you, this was a package here that we designed in 2005. That is watermelon, kiwi, blueberries, pineapple, and orange melon. And we had different modified atmospheres in each one of those lanes on that package. And there's still people, and now we're starting to see this kind of package in the US much more frequently. But this was 14 years ago in Europe. People were thinking about how do we do that kind of thing. So again, I encourage you to think outside of your own country and look at globally what's going on with innovation. Simplot, they're a small potato producer company up in Boise, Idaho. You may have heard of them. Arguably one of the largest in the world. They've come out with the innate potato, which is a GMO potato. Doesn't brown. You can cut it, you can put it on your counter, and it'll sit there and it'll be white the next day. It's an all potato GMO, by the way. But that required new packaging technology or a new application of packaging technology, and we chose the Landeck Breathable patch to be able to get what they needed to do because the physiological properties of that potato, because it didn't brown, were significantly different than other potatoes. And there were no additives, there were no sulfites. So here again, here's a produce item that required us to rethink how we were going to package it. You've all seen the spiralized vegetables by now. They're all over the place. But you take a baby carrot, you take a spiralized carrot, completely different respiration rates, completely different packaging required to package those two items, even though it comes from the same piece of produce. So again, every time you change geometry of produce, you're probably going to have to change the packaging. If it's a new geometry or a new type, then it's probably going to require a new type of package. Interestingly enough, Tarati, the company that kind of pioneered the whole, what they call streamer, funny streams of health, or the spiralized vegetables, they always had a little core left, the very core, and they actually started marketing that as a swizzle stick for Bloody Marys, and they actually got some mileage out of that, of being able to use that little core as the swizzle stick for the drink. Produce handling, we've come a long way from here to here, and Rudy showed this earlier. And that changes the rest from a packaging standpoint. That changes the respiration rate of the product going into the package. Marita's talked about, and she did yesterday, about manhandling some of this, or bruising and dull knives and whatnot. That all impacts packaging design, ladies and gentlemen. And these are areas that your packaging supplier isn't necessarily going to be able to help you with, because these are internal to your operations. So how you're handling your produce, how you're cutting it, how sharp the knives are. Is it going through an Urschel cutter? Some of those Urschel cutters are small aircraft engines. I mean, they will literally buzz through, and that can have just changing Urschel cutters can change the respiration rate of the product from a packaging standpoint. So again, a lot of the packaging development, new development, comes out of your own facilities and how you're processing your vegetables and fruits. So if we talk about actually packaging itself, what is packaging doing? So wrong button. We have come a long way in quantifying the respiration rate and how we do that. There are now commercial companies and commercial laboratories like ourselves that can help you quantify the respiration rate of your product. There are companies that sell what they call fast respiration rate meters. They're all good. They're tools, and you need to understand how those tools work. Everybody's method for measuring respiration rate is different. Is one better? No, it's different, and you need to understand how that piece of equipment or how that company or even how that university is measuring your respiration rate so you can make sure you can use that tool to your best advantage. This is one that a colleague of mine at Michigan State said is the next frontier for packaging, liquid management. Because historically, all of the polymers used in fresh produce and fresh cut produce packaging are liquid barriers, almost all. There's a couple of exceptions. So we've never really gotten involved in the packaging world in the whole how do we manage liquid. And we are now beginning to. We are now looking at how can our packaging impact how long you have to dry, or do you need to dry? Or in a case of a field pack, can we handle the high humidity of a field pack without it literally raining inside the package? So there's a tremendous amount of work being done in that area. We're talking about packaging that allows moisture to leave in a controlled manner. I mean, now the way you do packaging and allow it to leave is you leave it open and close it later sometime. But we're actually talking about high water vapor transmission rate packaging. The only one that's really on the market today is nylon, biaxially oriented nylon, which has 20 times a higher water vapor transmission rate than polyethylene, but it's also about 20 times more expensive. So it's a difficult thing to use in the produce industry. We're continuing to look at how can we get the transmission rate of the films higher and higher. How can we make them more breathable? We're going to talk about smart films. Remember when I said at the beginning of my talk 2 days ago, I said think of modified atmosphere packaging as a technology platform? And yes, we're going to monitor and control O2 and CO2. But now what we're starting to look at is, okay, can we affect ethylene management inside the package? Can we make the package an antimicrobial? Can we actually get to uniform gas exchange so the whole package breathes as opposed to just the perforations? And then we'll talk about sustainability and traceability a bit more in just a second. So there is a lot of work being done in the packaging industry to address each one of these topics. Now I'm here to tell you, ladies and gentlemen, if somebody comes to you and the story sounds too good to be true, it probably is. There's always going to be trade-offs. There's never going to be, gee, if you use this, all your packaging problems are going to be solved. It's going to biodegrade, it's going to recycle, it's going to have all this gas transmission rate, and it's 15% cheaper. It just isn't going to happen. So you're going to have to sit down and understand the science so you can make an informed business decision of does it make sense to employ that packaging technology. So this is a unique, this is the machine here that's going to do it. This is a press that you put in fresh cut produce. It squeezes it really hard, and this is the actual package itself. So inside this package is fresh cut produce. You put it in that machine, it creates about 20,000 psi of pressure, and out of the nozzle comes juice. And these are going to be in the next 2 to 3 months. This is actually the rebirth of a company that went out of business a number of years ago. They've figured out their issues and are restarting the company. Huh? The Juicero is the company that went out of business. This is not Juicero. Okay, they've corrected a lot of the problems that Juicero had. But from a package design standpoint, this is interesting because we have to be able to keep this fresh cut produce and then literally turn it into a liquid. And that package has to be able to, that spout has to open up when we want it to at a given pressure, and overall the package has to be able to withstand about 20,000 PSI. So it's from a packaging engineering and design standpoint, it's a fascinating challenge. But also, this is the direction that the industry is moving. How can we take a traditional way that we did something and do it differently? And how can packaging play a role in that? This is some of the artwork for those new designs. Correct. Now, in this case, that was the Juicero model. In this case, they put it through an HPP process first, just prior to the juicing. But yes, you're putting in fresh cut produce inside that package, put that refrigerated package into that machine. This is going to be like in a Whole Foods or in the back of a retail store, a Trader's Joe or something like that. You push the button, you put the cup underneath, and out comes 12 ounces of juice. Hmm? Say that again.
Kind of like the Keurig?
Yeah, it's a Keurig, yeah. Oh, and by the way, yeah, and which is an excellent point. So one of the other demands was, this has got to be recyclable, because they didn't want it to go into the landfill. Ultimately, it's going to be compostable. So from a package design standpoint, we have got this package that's got to hold fresh produce, it's got to squeeze, and then it's got to be completely recyclable or compostable, because unlike Keurig, they don't want it going in the landfill. No challenge. But fascinating, fascinating. This is a company out of Europe. They're Fresh Tech Liners. State Pack out of Israel has a very similar kind of, and these are high water vapor transmission rate bags used for field produce. So they actually let the moisture out, and then they control O2 and CO2. So very often when you're field packing and you tighten that bag around the melons or whatever, you're going to get a small rainstorm inside the package because of all the humidity. This will let that out. There's a number of companies, and I'm not allowed to talk about it yet because it's not quite commercial, but there's a number of companies, they're very close to breakthroughs on antimicrobial and also on incorporating ethylene management into the package itself. And I don't mean a sachet or a strip, I mean actually incorporating it into the polymers of the package. Something like that. Again, I'm not allowed to get into the details, but yes. Now, one of the challenges with antimicrobial packaging is historically, antimicrobial packaging works on contact. So if you have a bag of shredded lettuce, how much of that shredded lettuce actually comes in contact with the sides of the package? Very small percentage. So we are working on ways to increase the ability of the antimicrobial to get in contact with the pieces of produce. Will it ever be a 5-log reduction? No, I don't think so. But it will be another hurdle step that will aid to it. So talk to your packaging suppliers. Remember we talked about the other day about how your packaging supplier should be a technology resource that happens to provide you with packaging. Have these discussions with them. And if they have new products available, ask for the science behind it. Understand what it can and cannot do. So these packages are available today. This is a package that actually releases carbon dioxide into the package. So as the liquid filters through the absorbent materials, this is the stuff that's on the bottom of tomato trays. So as the liquid comes through and is separated from the tomato, you can actually begin to have active compounds that gas off. Now, this should look somewhat familiar to you all. Where have you seen something that sort of looks like that, where the liquid comes through and is trapped away from the product? Diapers, bingo. So diapers, bandages, adult incontinent, feminine hygiene, these are companies that are experts in liquid management and separating the liquid from. So when we were working on developing these kinds of products, we actually approached the companies who worked with Procter & Gamble and Kimberly-Clark, because even though it wasn't produce purge, they were experts, I mean experts in liquid management and segregating liquid away from, and if you can segregate the liquid away from a baby, you sure as heck can do it on a tomato. Believe me when I tell you, it's a whole lot easier, and the testing is much more civilized. So here again, this is where we went outside the industry. And we said, okay, what's a similar industry that deals with liquid and management? Well, that industry, healthcare industry, does it better than anybody. And when we looked at active compounds and moving through, we went to the medical field, because transdermal patches specialize in the metered release of drugs going into the human body. So how can we take that knowledge and apply it to the produce industry? So this is where I'm talking about, think outside of your existing industry and look at some of the technologies that may be able to be brought into our industry. Here's the tomato tray. That's commercially available. This is an old slide. I apologize. This is now Curation Foods, but this is the Landec membrane technology, a fascinating technology because the membrane can actually change its breathability with temperature. And it goes through, I think Jeff Breck mentioned it, on Monday, it goes through a phase change and becomes more permeable or less permeable. And there's some graphs about it. Big area of work going on is peelable, resealable. Being able to open that up, pull out what you want, and put it back again. And this came from Europe, ladies and gentlemen. Almost all of this technology. This is German. That's an Italian. I'm not sure which that one is. But that whole easy, open, peel, seal all came over from Europe, from the equipment companies. And it's easy to peel it open. The challenge is to be able to reseal it, and then peel it open, and then reseal it, and then peel it open.
I mean, after initial, you have to have some sort of method to avoid tampering, right?
It shows the tamper evident when you first open it, but then you can close it and open it again. Yes, you're right. You have to have that initial tamper evidence that shows that you've opened it. And here again, that came out of the healthcare field, the whole concept of the tamper evident, because in the operating room theater, when they open that package up of a sterile instrument, they have to show that it's not been tampered prior to and it had a perfect hermetic seal. So some of the same polymer technology that was used in the hospital and operating room theaters was transferred over to this technology. And there's a number of different types out there. What's coming on stream now are, instead of the conventional plastic tray, you now have peelable, resealable to more fiberboard or more sustainable types of packaging. And the polymers that are used to seal it to an APET tray are not necessarily, in fact, aren't the same polymers that you would use to seal to a different kind of tray. So if you're looking at going to different types of trays, understand that your peelable, sealable lidding film is going to have to change as well. And then just various different methods for getting that peel reseal. Combination meals, we've already talked about this. This was actually a photograph I took in 2005 in a European supermarket. Those, each one, almost every one of those packages, it's a horrible photo and I apologize, is some kind of combination meal, different kind of meal. And I do have a whole bunch, and here again, the Eat Smart combination meals that they allowed me to use. Okay, so this is, and unfortunately this has not gone as far as I would like to see it, but this is still in development. It's a company who developed and patented a breathable tray. So imagine that APET tray, instead of being all APET and not breathable, so all of your transmission rate had to be through the lidding film. Imagine if your entire tray was breathable. So again, you get this breathing all the way around. Thought it would be commercial right now. By now, it is not. Hoping it still will be at some point in time. And then there are different companies looking at temperature sensing, ethylene sensing, rightness sensing, all of these kind of smart packages where the package can actually sense and tell you whether or not something is ripe or not. One of the challenges with this kind of technology, there are some technology challenges, but there's also some cost challenges. And then what do you do with the data? It's one thing to generate this data, and it was said earlier, but then you got to do something with it. So if the package says, well, it's not quite ripe, are you going to pull it off the shelf? Are you going to kind of let it go? And that's been one of the challenges with incorporating so much technology into the package is, well, what are you going to do with it? And then the cost associated with that. This is one of the fast respiration rate meters I was talking about that's in the marketplace today. This is a company, pretty new, was in the high-tech business, still is in the high-tech business, computerized computer business, circuit boards and things like that. And this will be commercial in the next 6 to 9 months. They have actually developed a micro punching system to replace laser. And they claim they can go down to 40 microns with a micro punch, with much, much more consistent hole size than you generally see with a laser operation. Now, right now, they're ready to go forward with an intermittent, but they're working on one that'll go on a slitter rewinder up to 1,500 feet per minute. So it's actually small, small little micro punches. So stay tuned for that. I'm going to be with them at PAC Expo next week. They're going to be talking to some folks, but very, very exciting technology to be able, because laser perforations struggle to get down below about 80 microns in thickness. This can go easily down to 40 microns. You mean the donut hole? They've already, the hanging chad and all that. They've already addressed that. Yeah, they say they've got that addressed. Now, on an intermittent machine, it's pretty easy. That would run on a pouch, machine or a bag machine. At 1,500 feet a minute, they're still ironing that part out. But that's a great question. Huh?
What is actually making it?
A micro punch, a mechanical punch. Yeah. Very, 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 and this is a company that is world famous in the circuit board manufacturing. So they're used to dealing with extremely small holes and whatnot, and they're transferring that technology to fresh produce.
It just seems hard to believe that something mechanical would be more precise than the laser.
Well, one of the challenges with the laser technology, and they've come a long way, is that as the laser goes through the film, the energy is dissipated. And so you get more of a cone shape, and you can get some irregularities at high speeds. Now, the laser industry has done a lot of work to improve that, so it's a lot better. But one of the advantages with a mechanical punch is it's a very precise, as long as you don't tear the film. And that's where the challenge comes in, and that's what they're working on. Yeah, it's a little mind-boggling. When they first approached me about 6 months ago, I'm like, really, are you sure? But they've actually sent us a bunch of film that we've analyzed in the lab. And some of those pictures, in fact, those pictures are our pictures in the lab. Lots of new different kinds of laser perforation system coming on, as I just mentioned to Marita. There's a lot of work being done in that area to control laser perforations, make them that much more accurate. This is one of the gas analyzers that we were talking about. This happens to be the Felix model. The interesting thing with this one is that this can measure O2, CO2, and ethylene. So it's not just an O2 and CO2 meter, it's also an ethylene meter. This is the one we have in our laboratory, and we're very pleased with it. RFD smart cards being incorporated into packaging. Okay, this is one of, how much more time do I have? Oy. Okay, so what is sustainability? When I created this slide, I pulled these pictures off the internet, and the web pages that I pulled them off all said, look at our new sustainable package. I didn't say why, or how, or what, but they're all marketing it as sustainable. So sustainable is a big word and encompasses a lot. I mean, one definition of sustainable is your company continues to grow and make money. That's a sustainable company. So people somewhat abuse the term sustainability. And what you're now beginning to see, and this just happens to be a slide from this one company, is more of the circular economy. Okay, we're going to look, we're not just going to look at our product and we get it to you, but what's going to happen when you're done with it, and what's going to happen with the consumer. So sustainability is moving towards this more concept of a circular economy, or circular waste, and it comes all the way around. So when you think about sustainability, the abilities as I call it, you've got recyclability, renewability, compostable ability. By the way, there's industrial composting and consumer composting, and they're two completely different things. Industrial composting requires high heat in the composter. So if a product is industrial compostable, it will only compost in an industrial composter. It will not compost in your backyard. If it's backyard compostable, it is both. And there are now regulations and certifications that dictate how that works. There's degradable, oxy, bio, and then of course the proverbial landfill, which, by the way, as we all know, nothing degrades in a landfill. Newspapers don't, hot dogs don't. It is a sealed tomb. There's a famous study that was done in the late 80s, early 90s by Dr. Rathje at the University of Arizona. He's an archaeologist. He and his students went and dug up a 30-year-old landfill in Arizona, found newspapers that were still readable, hot dogs that were still in the shape of hot dogs, and carrots that were still carrots. So when you put it in a landfill, nothing happens for a long, long time. Certainly nothing with plastic, but also a lot of the other stuff that go into a landfill, not much happens. So people are looking at fiberboard as a way to replace plastic packaging. Very good option. But again, ladies and gentlemen, this is where I encourage you to look at the science, because there's advantages and disadvantages to everything. The advantage of the cardboard or the fiberboard, it's made from a renewable resource, trees. Disadvantage, a lot more energy to make it than plastic. It's also bulkier. So the same number of plastic bags, for instance, in San Francisco, when they banned the grocery store bag, it used to be 1 truck a week feeding all of the stores in downtown San Francisco. Now that they're using paper bags, it's 12 trucks a week supplying the same number of paper bags, belching out smoke and whatnot as they come into the city. Was it a bad idea? No, it wasn't. Did they take into account everything? No, they didn't. And this is what you need to do when you're evaluating some of these new kinds of plastic. This is, and a lot of people are working on this. This is one company that's working on completely recyclable packaging. So polyester packaging that is truly recyclable. There's a lot of grocery stores now that have in-store recycling, and there's companies like TerraCycle that if your community doesn't recycle, you can set it up with them and they will recycle for you. So there's a lot better recyclability streams than there ever have been before. So this is just a quick thing. I encourage you guys, when you can, to go on and look at this report, because it's fascinating to me. This was done by the Nature Conservancy and I think the World Health Organization. 85% of the ocean's plastics come from undeveloped Far East countries. Only 15 comes from developed countries in the world. So we could completely eliminate plastics, and we would only affect about 15% of the plastics found in oceans. China, Vietnam, Indonesia, India, and it's the countries that don't have well-designed waste systems. So they end up, the plastic waste goes into rivers, the streams flow into rivers, the rivers flow into the ocean. A lot of work being done on green polymers. Polynucleotides, polyamides, polysaccharides. A lot of work. There's now packaging that's coming out, being made out of tomatoes. We talked about the bioremediation with tomatoes. There are people that are making packaging out of tomatoes. There are people, the waste, tomato waste. Packaging being made out of potato waste. Packaging being made out of seaweed. This is my favorite, though. This is based on a renewable wood pulp, sourced from managed plantations, greater than 90% bio-based carbon content, home compostable, industrial compostable, suitable for anaerobic digestion, wastewater biodegradable, and marine biodegradable. And everybody in this room knows what that is. Anybody want to take a guess as to what plastic film this is? Bingo. This is cellophane. The first plastic film ever invented in the early 1900s from the cellulose of trees. And it's becoming a reinsurgence. They gave it a nice name, Nature Flex, instead of cellophane, but it's making a huge comeback. What's that? It depends if it's coated or non-coated. If it's coated cellophane, it's a barrier. If it's non-coated cellophane, it actually has some O2 and water vapor transmission rate properties. So we talked about the polymers from food products. This one is made out of mushrooms. This is my last slide. This has absolutely nothing to do with fresh produce. Absolutely nothing. But this is a classic example of why you should continue to look outside your industry. This is a tilapia skin that's used for third-degree burn victims instead of gauze. And what they've found is the healing rate is incredibly faster than the typical gauze that you put on third degree. What does that have to do with us? There was packaging designed to keep that product for up to 2 years so the doctors can use it. So very sophisticated package. Is it applicable to us? No, not necessarily. But that's the kind of thinking that's going on in other industries that I encourage you to continue looking as you're trying to decide where your packaging is going to go. Look at what other people are doing with it. Okay, so that was my second to last slide. Is temperature control important? Oh, come on, you got to be a little more enthusiastic than that. Thank you. Cold chain management? Incoming product quality, is that important? Post-harvest technology? What about the big L word? We saw those outside today. Doesn't work if there's leakers. Gas flushing, is it a tool or a be-all, end-all? Oh, thank you. Is this a static environment? No. Does one product fit all? No. And choosing the packaging the week before launch guarantees it's not going to be optimized. Right? Okay. Optimally designed packaging plays a critical role. Fundamentals must be covered. At the end of the day, what are the customer requirements, and what creative technology can be brought to bear to address those requirements. We supply a technical support service that happens to include packaging. Packaging must be an integral part of the entire new product development process, and the technology and supply of packaging is a global effort in a global market. Thank you.